The National Electrical Code, or NEC, provides comprehensive guidelines for electrical installations, including the use of cables and conduit. While the NEC doesn't explicitly forbid all cable types from being installed in conduit, it imposes specific requirements and restrictions that must be carefully considered. Understanding these regulations is crucial for ensuring electrical safety and code compliance. Firstly, it is important to define what is meant by cable. In the context of the NEC, a cable typically refers to an assembly of two or more conductors within an overall jacket or sheathing. Common examples include non-metallic sheath cable, often referred to as NM cable or ROMIX, and underground feeder cable, known as UF cable. The NEC also recognizes other types of cables, such as metal-clad cable, or NC cable, and armored cable, or AC cable. Conduit, on the other hand, is a raceway designed to protect conductors and cables from physical damage and environmental factors. Common types of conduit include rigid metal conduit, or RMC, intermediate metal conduit, or IMC, electrical metallic tubing, or INT, and flexible metal conduit, or FMC. The NEC addresses the use of cables and conduit in various sections, depending on the specific type of cable and conduit involved. For instance, Section 334.12 of the 2014 NEC provides restrictions on the use of non-metallic sheath cable, NM cable. While this section doesn't explicitly prohibit NM cable from being installed in conduit, it does limit its use in certain environments, such as wet or damp locations, unless the cable is specifically listed for such use. Installing NM cable and conduit in a dry location is generally permitted, but it's often not the most practical or cost-effective solution. Other wiring methods, such as individual conductors and conduit, may be more suitable in many cases. Underground feeder cable, UF cable, is specifically designed for direct burial applications and use in wet locations. Section 340 of the NEC covers UF cable. While UF cable can be installed in conduit for physical protection, it's generally not required unless the cable is exposed to damage. The NEC does not prevent UF cable from being installed in conduit. When installing any cable and conduit, it's essential to ensure that the conduit is properly sized to accommodate the cable without exceeding the fill capacity. The NEC specifies maximum conduit fill percentages in Chapter 9, Table 1, and Annex C, which vary depending on the number and type of conductors or cables being installed. Overfilling a conduit can make it difficult to pull the cable, damage the insulation, and reduce the ampacity of the conductors due to heat buildup. In addition to conduit fill requirements, it's also important to consider the bending radius of the cable. The NEC specifies minimum bending radii for different types of cables to prevent damage to the insulation and conductors. When pulling cable through conduit, avoid sharp bends that could exceed the cable's bending radius. Using appropriate pulling lubricants can also help reduce friction and prevent damage to the cable during installation. Metal-clad cable, MC cable, and armored cable, AC cable, are often used in conduit for added protection or in applications where exposed wiring is not permitted. The NEC permits the installation of MC and AC cable in conduit, provided that the cable and conduit are properly supported and secured. When using flexible metal conduit, FMC, with MC or AC cable, it's important to ensure that the conduit is listed for use with the specific type of cable being installed. Some types of FMC may not be suitable for use with certain cables due to their construction or materials. It's also important to consider the grounding requirements when installing cables and conduit. The NEC requires that all metal conduits be properly grounded to provide a low impedance path for fault current. This can be achieved by bonding the conduit to the equipment grounding conductor or by using listed grounding fittings. When installing non-metallic conduit, such as PVC conduit, a separate equipment grounding conductor must be installed within the conduit to provide a ground fault path. Furthermore, the NEC mandates the use of approved fittings and connectors for all conduit installations. These fittings must be properly sized and installed to ensure a secure and watertight connection. Using the wrong type of fitting or improperly installing a fitting can compromise the integrity of the conduit system and create a potential safety hazard. The NEC also addresses the issue of dissimilar metals in conduit systems. When using different types of metal conduit, such as steel and aluminum, it's important to take precautions to prevent galvanic corrosion. Galvanic corrosion can occur when two dissimilar metals are in contact in the presence of an electrolyte, such as water. To prevent galvanic corrosion, use compatible fittings and connectors or apply a protective coating to the metals. Another important consideration when installing cables in conduit is the environment in which the conduit system is located. The NEC specifies different requirements for conduit installations in wet, damp, and dry locations. In wet locations, such as underground or outdoor installations, use conduit and fittings that are listed for wet locations. These components are designed to withstand the corrosive effects of moisture and prevent water from entering the conduit system. In damp locations, such as basements or garages, use conduit and fittings that are suitable for damp environments. In dry locations, standard conduit and fittings can be used. The NEC also provides specific requirements for conduit installations in hazardous locations, such as areas where flammable gases or vapors are present. In these locations, use explosion-proof conduit and fittings that are designed to contain any explosions that may occur within the conduit system. Additionally, the NEC requires that all conduit systems be properly supported and secured to prevent movement or damage. The spacing between conduit supports depends on the type and size of the conduit, as well as the type of support being used. The NEC provides tables and guidelines for determining the appropriate support spacing for different conduit types. When installing conduit in concealed locations, such as within walls or ceilings, it's important to ensure that the conduit is protected from damage. The NEC may require the use of additional protection, such as metal sleeves or barriers to prevent nails, screws, or other objects from penetrating the conduit. The NEC also addresses the issue of abandoned conduit. When a conduit system is no longer in use, it must be properly abandoned to prevent it from becoming a safety hazard. The NEC requires that all abandoned conduit be removed or sealed to prevent the entry of water, dust, or other contaminants. In addition to the general requirements for cable and conduit installations, the NEC also includes specific requirements for certain types of installations, such as underground installations, service entrances, and feeder circuits. These requirements vary depending on the specific application and the type of equipment being served. When planning an electrical installation that involves cables and conduit, it's essential to consult the NEC and any applicable local codes to ensure compliance. The NEC is a complex document, and it's important to have a thorough understanding of its requirements before beginning any electrical work. It is also recommended to consult with a qualified electrical inspector or engineer to ensure that the installation meets all applicable codes and standards. In summary, while the NEC does not universally prohibit the installation of cables and conduit, it imposes various requirements and restrictions that must be carefully considered. These requirements address issues such as conduit fill, bending radius, grounding to similar metals, environmental conditions, and support spacing. By following the NEC guidelines and consulting with qualified professionals, ensure that cable and conduit installations are safe, reliable, and code compliant. Firstly, consider the type of cable being used, whether it is non-metallic sheath cable, underground feeder cable, metal-clad cable, or armored cable. Secondly, select the appropriate type of conduit for the application, such as rigid metal conduit, intermediate metal conduit, electrical metallic tubing, or flexible metal conduit. Thirdly, adhere to the NEC conduit fill requirements to prevent overheating and ensure ease of installation. Fourthly, maintain proper bending radii to avoid damaging the cable's insulation. Fifthly, ensure proper grounding of metal conduits to provide a safe path for fault currents. Sixthly, use approved fittings and connectors to maintain the integrity of the conduit system. Seventhly, take precautions to prevent galvanic corrosion when using dissimilar metals. Eighthly, select conduit and fittings suitable for the environmental conditions such as wet, damp, or hazardous locations. Ninthly, provide adequate support and securement for the conduit system to prevent movement or damage. Tenthly, properly abandon any unused conduit to prevent it from becoming a safety hazard. By paying close attention to these details and consulting the NEC, one can ensure that cable and conduit installations are performed safely and in accordance with the latest electrical codes. Remember to always prioritize safety and consult with qualified professionals when working with electricity.